3, 2, 1, we have ignition, we have liftoff. The program is on time, the response is normal.
In 1977, the Titan IIIe rocket ignited its engines for what was one of the most audacious missions ever attempted by all of humanity. To exploit a rare alignment of Jupiter, Saturn, Uranus, and Neptune, so that the Voyager 1 and 2 probes could take advantage of gravitational assist to, let's say, hop from planet to planet, saving fuel, and carrying out an unprecedented exploration of the 4 gas giants. Later, the probes would enter interstellar space where they are currently located. On board each of the probes, there is a gold-plated record on which 115 encoded images have been recorded, representing the diversity of life and culture on Earth. Like photos of people eating, photos of houses, a river, a fetus, among others. It also includes Earth sounds such as rain, volcanoes, and earthquakes. Greetings in more than 50 languages, and it even contains songs from some of the greatest artists of all time, like the Beatles, Beethoven, Mozart, among others. The whole idea of the records was conceived by some of the brightest minds, with the goal of serving as a kind of time capsule, an interstellar message for extraterrestrial civilizations. That is, peoples who are somewhere or on some other planet in the vastness of space. Do such civilizations actually exist? To begin with, what is an extraterrestrial? Is extraterrestrial short for extraterrestrial? Scientifically, extraterrestrial refers to anything that originates outside of Earth, from the Latin extra, which means outside, and terrestris, which means belonging to Earth. And it doesn't have to be life. A rock or meteorite that falls from space is extraterrestrial matter. An unknown object is extraterrestrial matter. If it's life, it could be anything from a microscopic bacterium to a complex civilization. Astrobiology, also known as exobiology, is the official scientific field, often led by National Aeronautics and Space Administration and the European Space Agency, that studies this question. In it, an extraterrestrial probably doesn't look like a humanoid. The search for extraterrestrial life mainly focuses on microbial life, that is, simple organisms that can survive in extreme conditions somewhere outside of Earth. This search is especially carried out in the underground oceans of moons like Europa, which is one of Jupiter's moons, and Enceladus, one of Saturn's moons, or even in the subsurface of Mars. However, the search covers the entire observable universe. In this context, a real alien could be a bacterium that eats minerals at the bottom of a dark ocean, never having seen sunlight. For Peter Ward and Donald Brownlee, 2 American scientists who study the possibilities of life beyond Earth, simple aliens, like bacteria, may be very common in the universe, but complex aliens, like animals or intelligent beings, are extremely rare due to the need for very specific and unstable conditions for billions of years. But what are these conditions and how specific and unstable do they need to be? As Nobel laureate Enrico Fermi asked, if the universe is so vast, where is everyone? Well, if you're watching this video, you're probably on planet Earth. The only planet in the observable universe with the specific conditions needed for life: humans, animals, plants, viruses, bacteria, and more. Outside of it so far, no other planet in the entire observable universe has such conditions for these forms of life to exist. For a planet to be able to sustain human life, and not just microbial or simple life, the requirements are very strict. It's not enough to just be in the habitable zone, which is a concept we'll see in a moment. A fine balance of various physical and chemical conditions is required. To make it easier, We can divide these conditions into two scenarios: immediate survival, being out there on some planet without dying instantly, and long-term habitability, being on such a planet for long periods and building a civilization. The first fundamental pillar is the right atmosphere, breathable air. It's not enough to just have air, it needs to have the right recipe. The pressure needs to be enough to prevent the water in your body from evaporating. Below 0.06 atm, known as the Armstrong limit. Saliva and other body fluids, like blood and water, would boil at the body temperature of 37 degrees Celsius. Above 5 atm, the pressure starts to affect the nervous system, causing confusion and euphoria. So, ideally it should be above 0.5 atm to live without pressurized suits, which are those astronaut suits. Besides that, we need a partial pressure of oxygen similar to Earth's, about 21% at sea level. Too little causes hypoxia or suffocation, and above 35 or 50%, everything becomes flammable. Besides being toxic, an atmosphere with 100% oxygen would make any spark result in an explosion. There would be constant forest fires, and human and animal life would face oxygen poisoning, leading to organ failure, pulmonary swelling, and death. It's also necessary for the air not to contain high levels of carbon dioxide. Above 1%, humans become drowsy and develop acidosis. Above 5 to 10%, it's fatal. For comparison, on Earth, the concentration is about 0.04%, and on Mars, it's 95%. That partly explains why there's no life there. Besides the atmosphere, there needs to be liquid water on the surface, or at least below it. For humans, water isn't just for drinking, it's essential for agriculture and thermal regulation. It acts as a universal solvent for transporting nutrients and eliminating toxins, regulates body temperature and thermoregulation, and participates in essential chemical reactions, being fundamental for survival, the balance of biodiversity, and the functioning of all cellular and bodily functions, including digestion and hydration. Another important factor for the existence of life is the presence of a tolerable gravity. Our bodies have evolved to function at 1g Earth's gravity. In microgravity or low gravity environments, such as in Earth's orbit, in the case of the International Space Station, or on the Moon, or even on Mars, the human body experiences loss of muscle and bone mass, meaning less muscle and weaker bones. Vision becomes blurry, the immune system gets weaker, and so does the heart. If gravity is high, like for example 1.5g or 2g, which means everything becomes twice as heavy, the heart would have trouble pumping blood to the brain. The bones would be under twice as much stress, which could easily cause fractures from everyday movements. One peculiarity of living in a high-gravity environment is that humans would be shorter, stronger, with denser bones, but with reduced mobility. In other words, they would move more slowly, jump very little, and running would probably be something that only a few people could do. There's also the issue of the planet's radiation shield, fertile soil, ideal temperature, not too hot, not too cold, among other things. All these factors mentioned are directly responsible for the existence of all life on Earth as we know it. A sudden change in any of them can, without a doubt, put all living beings at risk. And the absence of any of them also prevents the existence of life as we know it. And, in addition to that, there is the concept of the habitable zone, also called the Goldilocks zone, which is the region of space around a star, where the conditions are just right for the existence of life as we know it. In simple terms, it's the range of distance where it's not too hot nor too cold. For astronomers, this is the region where a rocky planet with an atmosphere can maintain liquid water on its surface. And it's exactly in this region where planet Earth is located, about 149.6 million kilometers from the Sun. Earth, which is the third planet closest to the Sun, is in a habitable zone. In other words, at this distance, the temperature is ideal for living beings to survive and for there to be liquid water and complex life. It's not so hot that water evaporates like on Venus or Mercury, nor so cold that it freezes like on Mars, Uranus, or Neptune. Enabling photosynthesis, a stable atmosphere, and ecosystems, along with the sun's rays reaching us more parallel and shielded by the atmosphere. In other words, it's the delicate combination of all these factors that allows life to exist on Earth. And it's this delicate dance of small changes in them that makes life on Earth as we know it possible to this day. But why only on Earth and not anywhere else? On July 23, 2015, National Aeronautics and Space Administration announced discovering a planet similar to Earth. So similar that it was nicknamed Earth's bigger and older cousin. Kepler 452b, which orbits in the habitable zone of a G2 type star, which is very similar to the Sun. The planet takes 385 Earth days to orbit its star, which is very similar to Earth's 365 days around the Sun. It is about 60% larger than Earth, and it is estimated to have a gravity twice that of Earth. It's just not certain whether it is a rocky planet like Earth or a gas giant. But the biggest problem is that it is 1,400 light years away from our solar system. To give you an idea of that distance, traveling at 61,200 kilometers per hour, which is the speed of the Voyager 1 probe, it would take 24.7 million years for us to get there. Along with it, several other Earth-like planets have already been discovered, such as Kepler 442, b Kepler 186, F Teegarden b, transiting planets and planetesimals, Small Telescope, 1e Proxima, Centauri b, transiting exoplanet survey satellite object of interest, 700D, Gliese 667 CC, among others. With Teegarden b already confirmed as a rocky planet and with a surface temperature of 28 degrees Celsius, it is one of the most likely to sustain some kind of life on its surface. However, on none of these planets has the existence of any kind of life ever been proven, not even in the form of small organisms, plants, or more complex beings. That's because on all Earth-like planets, although many have the right size, gravity, ideal orbits, and are even in the habitable zone, they lack a precise combination of essential factors, such as a stable atmosphere, a protective magnetic field, abundant liquid water, active geology, enough time for the evolution of complex life like volcanoes, tectonic plates, and a carbon cycle that regulates the climate. Earth is an extremely rare package of all the conditions necessary to sustain complex life. The Moon is also in the Sun's habitable zone like Earth. However, due to its much smaller size, it has much less gravity and is unable to retain an atmosphere. The star of the planet Kepler 452b, for example, is 1.5 billion years older than the Sun. Over time, the star became brighter, heating Kepler 452b and possibly causing a runaway greenhouse effect, like on Venus, boiling the water. The only thing that can prevent this and allow for more Earth-like temperatures is if it has an atmosphere with the right composition, which is still not known for sure. In other words, to sum up, the term extraterrestrial refers to anything of origin outside Earth. It can be a rock, dust, an object, or even a being. Second, with all the knowledge we have and all the studies and observations already done, We've only found life in the form of microorganisms, plants, animals, and human beings here on Earth, which is the only place that brings together all the delicate elements in the right composition and measure for living beings to exist. Plus, it's in its star's habitable zone. Third, although several planets outside our solar system have already been discovered that also bring together all or most of the delicate elements in their composition, and at just the right amount for life, yet something is always missing. Fourth, and finally, the possibility of there being humanoid ETs is extremely remote. The greatest chance if ETs exist in the universe is that they are in the form of small microorganisms.